Elastic property of the materials is a second unit for the mechanical, civil, aeronautical, engineering students. Today, I will start to the elastic property of the materials. Introduction for the elastic property of the materials. The materials can possess mainly four fundamental states of the matter. Number one, solid. Number two, liquid. Number three, gases. And number four, plasma state. Solids. Solid are the one of the four fundamental state of the matter. Here are some key properties of the characteristics of the solids. Properties of the solids means it has this definite shape and definite volume. Means solids are maintain their shape and volume unless subjected to the external force. Solids are the rigid. Solids resist the change in shape and volume. Solids are the fixed density, which is the mass per unit volume. Solids are the less compressibility. It is a incompressibility compared to the liquids and gases. Types of these solids means many types of solids is the crystalline solids, amorphous solids, metallic solids. And also some other properties of these solids is the thermal expansion, elasticity, plasticity. Example for the solids means rock and minerals, metals and alloys, ceramic and alloys, ceramics and glasses, plastic and polymer, wood and other biological materials. Next, second matter state means liquids. Liquids are the one of the four fundamental states of the matter. Some properties of the liquids means it has the definite volume, it has the no definite shape. Means and also mean that they in volume of the liquid maintain there unless subjected to the external force. It is also mean that the compressibility mean that they very less. Means these are the incompressibility, meaning they cannot be easily compressed. Means and also it has this viscosity. Liquids resist the flow and they have the measurable viscosity. Means types of the liquids means Newtonian liquids, non-Newtonian liquids. Newtonian liquids and non-Newtonian liquids. Some properties of the liquids means fluidity, surface tension, capillary action. Means these are already mean that you studied means 8th, 9th standard and also first PU, second PU. What is the fluid? What is surface tension? What is the capillary action also? Example for the liquids, water and other aqueous solution, oils and fuels, blood and other fluid bodies, juice and other liquids. Next, another state means gas state. Gas are the one of the four fundamental states of the matter. Some properties of the gas means it has the neither shape nor volume. It has the mean that the low density, and also it has the highly compressibility, and also mean that it has the mean that the viscous mean they flow easily. Types of the gases means so ideal gases and real gases. See, we know already means ideal gases means you derived means PV is equal to nRT. Means example for the ideal gas, helium gas, hydrogen gas, nitrogen gas. Real gases mean that it is a other than ideal gases. Means it has the behavior intermolecular forces. Example for the real gases means carbon dioxide, ammonia, etc. Means these are the mean that the types example for the gases. So some special characteristics of the gases means that they expansion, diffusion, pressure, temperature. Example for the gases means atmospheric gases, noble gases, fuel gases, toxic gases, etc. Means these are the example for the gases. Another state of the matter means plasma state. Plasma is fourth state of the matter in addition to the solid, liquid, and gases. Some properties of the plasma means it is a ionization property. Plasma is the collection of the charged particles, including ions, electrons, and neutral atoms or molecules. Plasma or the high energy. Plasma is the typically formed at high temperature, which ionize the atom or molecule. Plasma or the conductivity. Plasma is an excellent conductor of the electricity. Types of the plasma, there are two types of the plasmas: natural plasma and also artificial plasma. Natural plasma means that they such as in stars and lightings. Artificial plasma means that they it is a generally created in laboratory, in means research laboratory or industrial settings, means in TV plasma and fusion reactors also. Some characteristics of the plasma: high temperature plasma or the high temperature, and also low density, and also mean that the high energy density. Example for the plasma: stars, lightings, plasma TVs, fusion reactors. See, these are the example for the plasma. And mainly mean that they what is the main difference between the solid, liquid, and gases? Mean that the solid are the very good force of attraction, because of mean that the very small small distance between the force of attraction between the means very small distance between the molecules. In liquids mean that they it has the mean that they less force of attraction between the molecules, because of mean that they it is a average, means it is a very large, it is a large for the distance between the two molecules when I compared to the solids. Gases are the very weak for the good force of attraction between the molecules, because of mean that they very large for the intermolecular distance between the molecules. Means mainly solids, means solids, liquids, and also can possess the elasticity property and also plasticity property. Elasticity property mainly can possess to the solid materials. Means what do you mean by elastic property of the materials, or mean that what do you mean by elasticity? Means we know rigid body. Rigid body means no deformation. Means when even the small apply to the force, I mean small deformation, or mean that they when it producing for the small deformation. Say elasticity means it is a property of the material by virtue of it's a do not regain to the original shape and size after removing of the deformation forces. After removing for the deformation forces. See, bodies exhibiting this property is called the elastic bodies. If the body regain its original shape and size completely after deforming forces are removed, then the body is said to be perfectly elastic. Perfectly elastic. But example for the elastic materials mean that they springo, rubber means rubber. It is not plastic. It is a rubber, and also some steel wires. These are the some example for the elastic materials. Means in practically mean that they no body is perfectly elastic material. Quartz fiber can be taken nearestly elastic body. Say some of the materials mean that they cannot regain to the original shape and size when a removal of the deformation forces. That property of the materials is called the plasticity. Plasticity. Bodies exhibiting this property is called the plastic bodies. If the body retains completely its a deformed size and shape after deforming forces are removed, called the perfectly plastic body. In example for the plasticity materials means all plastic materials, all plastic materials. In practically means that nobody is a perfectly plastic behavior. Ordinary mud means can be taken to the perfectly plastic body. All bodies elastic or plasticity lies between these two limits. Means These are the difference between the elasticity and plasticity. Say deformation forces. What do you mean by deformation forces? We use the deformation forces word. When a removal of the deformation forces, it's regained to the original shape and size. That property is called the elasticity. You told means what do you mean by deformation forces? Means deformation forces means it is a stress. It is a stress. Stress means the force acting per unit area. The force acting per unit area. When a force acting on the body producing deformation, the internal reaction which tends to restore the original condition is called the stress. The force acting per unit area is called the stress. The magnitude or measurement of the stress force applied per unit area. The stress developed is equal to the opposing deforming forces. Means the restoring force is equal to deformation forces when the body in equilibrium. What is the unit for the stress? Newton per meter square. Force unit SI unit Newton. Area unit is SI unit meter square. Newton per meter square. There are three types of the stresses. Tensile stress. It is also called as the linear stress. Longitudinal, also called as the longitudinal stress. Number two, volume stress, compressible stress, and one more stress means that the volume bulk stress. Next, last type of stress means tangential stress and shear stress. Tensile stress or linear stress or longitudinal stress. The tensile force acting per unit area of the materials is called the tensile stress or linear stress or means longitudinal stress. Example for the linear stress or compressible linear stress or longitudinal stress, tensile stress means tongue of fork, bicycle chain rotating. The belt is rotating on the pulley and roof. These are the example for the tensile stress. These are the example for the tensile stress. Tensile stress. Say here original length of the rod or material when a force is acting at the end of the rod means it is a L naught is the it is a compressing of the it is change of the uh, change in dimension of the rod means tensile stress force acting per unit area of the materials means it is denoted by sigma F by A naught. Say compressible stress. Next another type means compressible stress. This compressible stress is also called as the bulk stress and also volume stress. Say the compressible force acting per unit area of the materials is called the compressible stress or volume stress or bulk stress. Say here in a well knot is the original length of the material or cylinder means when a compressing the body means it is a getting to the L means this is a uh, compressible stress means uh, compressible force or bulk force acting per unit area of the materials is called the compressible stress. Shear stress or tangential stress. Say when you take the cube, it has the six faces. When you apply, you take the hammer, when you applying the tangential force on the top of the surface, tangential force. The cube means it is a changes to the slightly. Say the shape it changes. Say the shape it changes means it is a original shape of the wall cube. It is a slightly bending means it is a changes that is called the theta. It is a theta means it is a changes. This it is a in shear stress whenever they apply to the shear force acting per unit area of the materials when it changes to the shape of the body but is not changes to the volume of the cube. Means what is the definition for the tangential stress or shear stress? Means the tangential force acting per unit area of the materials is called the shear stress. It is called the shear stress. So example for the shear stress means when when a scissor cutting to the sheet, the axle connecting two wheels. And also another example means it is a changes shape of the body. It is not changes to the volume of the body. Means how to remove the water from the wet cloth. Means when you keep the two hands, means when it twisting, means it is a changes to the, it is a remove water coming from the cloth, but it changes to the shape of the body, but is not changes to the volume of the body. Shame means that they another previous example also bulk stress or compressible stress means it is the changes to the volume of the body, but it's not changes to the shape of the body. Means suppose means if you take the volleyball, uh, two volleyballs you take it, means if you mean that they some amount of gas one large amount of gas one volleyball, another volleyball means some amount less amount of wear, means it is the shape is same but it changes to the volume, correct? No, say these are the compressible stress. Another example means that the fillers supporting in the super building, the springs in the automobiles, and the springs in the train, and I also mean that the legs supporting in the chair. See, these are the example for the compressible stress. Means tangential stress. See, these are the tangential stress. Tangential force acting per unit area of the materials is called the tangential stress or torsional stress. Means the torsional force acting per unit area of the materials is called the torsional stress. The next another word is there. Whenever the force acting per unit area of the materials mean that the body also changes. This changes compared to the original dimension. That physical property is called the strain. What do you mean by strain? Means generally used to the strain. Means suppose means you working places mean that the morning mean that the high energy is there, when after evening mean that they when compared to the morning means less energy is there, you getting to the strain. What this one means that they when a comparison means when a ratio means that the original change in energy to the original energy, that is called the generally strain. Say here means that the strain, the ratio of the change in dimension to the original dimension, the ratio of the change in any dimension to its to the original dimension is called the strain. Here also mean that there is no unit for the strain because of mean that the ratio of the two quantities having the same. Means ratio of the change in dimension to the original dimension, change in energy to the original energy, change in length to the original length, change in volume to the original volume. Same means that the ratio of the two quantities having the same. Therefore, there is no unit for the strain. There are neither unit nor dimensions. Dimensional less quantity means neither nor dimension. Means it is a dimensional less quantity. Types of the strain: longitudinal strain, shear strain, and volume strain. Longitudinal strain, tensile strain, it is also called as the linear strain. Shear strain, it is also called as the mean that the tangential strain. Volume strain or bulk strain or compressible strain. These are the different types of the strain. Longitudinal strain or tensile strain, the ratio of the change in length by original length. Means example mean that the bicycle chain, or mean that the belt is rotating on the pulley and rope. Means it is a change in length by original length. The ratio of the change in length by original length. There is no unit. Shear strain. It is a means that the theta means the ratio of the lateral displacement of the body to the original dimension of the cube is called the shear strain or tangential strain. Volume strain or bulk strain or compressible strain, The ratio of the change in volume to the original volume is called the volume strain. Volume strain. So a longitudinal strain means you consider to the one cylinder or one material, means it is a area A. When a force is applied to ends, means that the F. Original length of the material means L. When a changes, means that the L naught. Means actually this is a original length. It is a change in length, means L you take it. Means change in length by original length, that is called the delta L. L minus of L naught is called the difference L naught, delta L. This is a longitudinal strain, change in length by original length, delta L by L. Shear strain. See, shear strain means it is a take the Q, all sides are equal. It is a each side means L you denote it. Means here, uh, see, it is a upper surface, EFGH upper surface. Say when a tangential force is applied on the upper surface of the cube, say that is a F, means it is a slightly bending shape of upper surface of the cube, means it changes, means that the corners shape of the top surface of the shape of the cube means E dash, F dash, G dash, H dash. Means original shape of the body means that the E, F, G, H. It is a G changes to the G dash, E changes to the E dash, F changes to the F dash, H is changes to the H dash. Means when applied to the tangential force, the upper surface means it is upper surface it changes, the lower surface it not changes. Means the changes means it is not by theta. Means it is this lateral displacement is called the delta L. See what lateral displacement means, when a displacement of the body perpendicular to the direction of the force applied is called the lateral displacement. Linear displacement means when a displacement of the body is a parallel to the applied to the deformation forces is called the means linear displacement. But here lateral, when a force is applied like that, means that the downward, means it is a changes, means that the delta L perpendicular to the direction of the tangential force applying on the, so on the upper surface of the cube, delta L. Means shear strain is denoted by theta is equal to delta L by L, the ratio of the lateral displacement of the cube to the original dimension of the cube is called the shear strain or tangential strain. Next, volume strain. Volume strain means change in volume, the ratio of the change in volume by original volume. Say, when you take the one of the cube, when a force is applied to the inward to the cube, means it is a changes to the cube, means the changes is called the delta V, change in volume. Means it is a original volume means V, means the ratio of the change in volume by original volume. It is called the volume strain or compressible strain or bulk strain. Say example mean that the filler supporting in the super building, the legs in the chair, the legs in the table, the springs in the automobile, springs in the train. These are the example for the volume strain. Shear strain means same the scissor cutting sheet, the axle connecting two wheels. Same mean that I told no shear stress. So same example belongs to the shear strain. And linear strain or mean that the uh, tangential strain. Same means the bicycle chain, the tongue of war, and also uh, belt rotating on the pulley and rope. See, these are the different types of the stress and strain. So almost all solid materials means the stress is directly proportional to the strain. When a stress is increases, the strain is also increases. Stress is directly proportional to the strain within the elastic limit is called the Hooke's law. Hooke's is the one of the scientist name. He is observed to the elastic material behavior of the elastic materials. It states that st- stress is directly proportional to the strain within the elastic limit is called the Hooke's law. It is found experimentally for many substrates that the strain produced by the given stress is directly proportional to the strain. When a stress is gradually increases, the strain is also increases. The maximum value of the stress above which the linear relation between the stress, the strain ceases to the be valid to the term as the elastic limit. The material and the consideration for the particular type of the stress applied. Hooke's law, stress is directly proportional to the strain. Stress is equal to constant into strain, but proportional constant. Cross multiplication, stress by strain is equal to constant. This constant is called the moduli of velocity. It is a moduli of velocity. What do you mean by moduli of velocity? Within the elastic limit, the ratio of the stress by strain is called the moduli of velocity. The unit of the moduli of elasticity means Newton per meter square. Stress unit is a Newton per meter square. Strain no unit. Stress by strain means it is a Newton per meter square. It is called the moduli of elasticity. What do you mean by elastic limit? What do you mean by elastic limit? The constant taken is known as the moduli of elastic, depends upon the material of the body. Maximum force is applied, maximum limit or maximum deformation forces is applied. The body it's reagain to the original shape and size when a removal of the deformation forces. This maximum limit or deformation force limit is called the elastic limit. It is called the elastic limit. Moduli of elasticity. Stress is directly proportional to the strain within the elastic limit. Stress by strain is equal to moduli of elasticity. This moduli of elasticity based on materials can observing many types of moduli of elasticity is there. Mainly three types of the moduli of elasticity: Young's modulus, bulk modulus, rigidity modulus. Young's modulus is observed to the only solid materials. Bulk modulus, it is observed to the liquids and gases. Rigidity modulus can observe to the gases and upper surfaces of the liquids. These are the classification of the elastic modulus. Three types of the moduli of velocity: Young's modulus, bulk modulus, rigidity modulus. Okay, you continue for the next class. What do you mean by Young's modulus? What do you mean by bulk modulus? What do you mean by rigidity modulus?